Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 128. Please turn to it. Page 128, problem number 3 is the exact same problem that we did long time ago on day number 24. We are redoing it right now at a little bit of a faster pace. Here's the problem. It says which of the following statements must be true. That's the important part. Which of the following statement must be true. We might find something that may or may not be true. We're looking for something that has to be true all the time. Statement number 1 says, in 2008, store R has greater sales than any of the other 4 stores. It says in 2008, store R, among the 5 stores that they give us, I believe there are 5 of them, PQRST, we are told that store R is the one with the highest sales in 2008. The problem is that we are only given percentages. No dollar figures are given. No dollar figures are given. No dollar figures are given to us. Therefore, statement A may or may not be true. We cannot say for certain. We cannot say for certain that store R didn't indeed have the highest sales among all the stores because we don't have any dollar figures. Statement A is not something that must be true. It may be true, it may not be true. Let's move on to statement B. In statement B, they tell us that for store S, sales in 2008 were 22% lower than in 2006. Well, what we find is that from 2006 to 2007, we see a drop. We are told there is a drop in the sales, drop of 7%, we are told, and then they go on to tell us that from 2007 to 2008, there is another drop of 15%. Therefore, people in their haste might think that, well, if there is a drop of 7% and then another drop of 15%, then that means that there must be a drop of 22%. That reasoning is flawed. That reasoning is not correct. And all we have to do to understand that part is to think logically. A drop of 7%, a drop of 7%, and then another drop of 17%, or is this 15%? Another drop of 15%. It would have to be 15 because they add up to 22 here. Does not represent an overall drop of 22%. It does not represent an overall drop of 22%. And to understand this concept, instead of working with the numbers that they give us, we can actually make up something that actually brings out the point quite saliently, quite obviously. Look, if we start out, if we have a drop of 50%, a drop of 50%, and then another drop of 50%, does not imply that the quantity will disappear. Does not imply that the quantity will disappear. And the easiest way we can show that is that if we start out with a 100, a drop of 50%, that means that it becomes 50. That's a drop of 50%. And then if it's on the drop of 50%, does not mean that the 100 will become 0, because the point of reference is different. It's a drop of 50% of this quantity, not the initial quantity. It's a drop of 50% from where we started out from, here, right here in the beginning of the story, which is this part, not the very first number. So it becomes 25. So its point of reference is not the same. When we talk about the percentages, percentages are not calculated based on what you start out in the beginning, but what you start out this period from. So here a drop of 7% and a drop of 15% is not going to equate to a drop of 22%. For example, if you start out with 100, it becomes 93, it's a drop of 7%. And then from here to here, it's a drop of 15%. If a drop of 50% means that you have 85% of 93. And that amount, because you're taking 0.85 of 93, not 100, it's going to be a smaller amount than 100 minus the 22. So a drop of 7% and then a drop of another 15% is actually less than an overall drop of 22%. So the second statement says, let's see exactly how they phrase it. The dollar amount sales at store S for 2008 was 22% less than that for 2006. No, it was less than 22%, not 22% less. Second statement is also false. Second statement is also false. Let's move on then. Third statement. It says for store R, sales in 2008 were more than, that's the important part, more than 17% greater than in 2006. Well, let's find out, shall we? So in 2006 here we have, then we have our 2007, and then we have our 2008. So if we start out with a figure of 100 for 2006, first we are told that we have an increase of 5%. So increase of 5% from here to here, increase of 5% means that this guy becomes 105. And then we are told that we have another increase of 12%. An increase of 12%, but 12% of what? Not 12%, not 12% of 100, but 12% of what we started out here, the second year here, 2007. So 12% of 105, 12% of 105 is of course 12% of 105 is of course greater than 12% of 100. So the final change that we will have will indeed be more than 17%. So this time around they are correct. If you have an increase of 5% and then another increase of 12%, the overall increase actually is more than 17%, as opposed to just having one increase of 17%. Because if you have just one increase of 17%, it's just 17% of 100, which is 117. Here, the final amount is going to be more than 117. So the increase is more than 7%. You don't have to waste your time to actually do it out. Nobody's asking us to do it out. We just have to realize, we just have to understand conceptually. It's the same concept as we did in statement B. The concept here is that if something goes up by 5% and then another 12%, the overall increase is more than 17%. Do you understand? That's all. That's all. So this statement C is correct. As I said before, if you need more help in this thing, if you're weak in percentages, and if you need more help in it, if you need to go in more detail, you can always watch the original videos where the same problem is done in a great deal of depth, and that will be day number 24. All right. I'll see you tomorrow. Okay. Bye now.